So hope you're all healthy and safe at your home and you're doing well. Okay. So the main agenda of today's session is automotive design workshop. Okay. So coming to myself, I'm Raj Pujari and I've been in this CAD training domain for more than 4 years now. Okay. I've successfully conducted batches for more than 100 batches of students as well as working professionals. I've worked on softwares like AutoCAD, SolidWorks, CATIA, Rio, then there is NXCAD, MasterCam, and I've also worked on consulting projects for Hypermesh as well as ANSYS. So any doubts throughout the session, any doubts regarding the CAD softwares or any of the analysis softwares or in general, mechanical or be it automotive, aerospace, you can let us know. So I want this session to be an interactive one. Okay. Let us not just make it like some boring sessions like we have usually people would be talking and the host would be talking, going on and on, and people would be just listening. Let us make this interactive. Okay. You share what knowledge you have and I'll share all my knowledge that I can give to you. Okay. Fine then. So everybody please do respond in the chat box. So let us see the audience today here. So people from mechanical background, please type MEC, and people from automotive, please type AUT. Let us see the audience today. Okay, so let me tell you what do you mean by automotive? Can anyone answer that question? What do you think? What is automotive and what is automobile? Okay then, fine. So let us begin with the agenda. So today's agenda is PLM. We'll start with PLM. Okay. Then we'll go on with the next sessions. That is introduction to automotive design. Then we have segment of different cars and we have BIW. We have stages in design process, factors influencing automotive design. Okay. So I'll be the trainer for this entire session of 2 days. Okay. So let us learn a lot about automotive design and get an information about all the various CAD software that are used in this. Okay. See, as from the student's point of view, most of you would be, you would have heard of AutoCAD, you would have heard of SolidWorks, or you would have heard of industrial design, but you don't know what exactly that means, isn't it? So you would have just known that there's something called a design segment. So usually your friends or someone would have told that I'm working in production or I'm working in operations, so they have to go and do quality checking or they have to do some, this manual work. But when it comes to designing, it sounds interesting to everybody. It's you feel as if you're creating something, you feel as if you're giving life to some product, isn't it? That is exactly the essence of design. I think someone's microphone is on. Please mute yourself so that we have a clear audio here. I think it's Nischal. Yeah, please mute yourself, everybody. Okay, it would be great. Yeah, thank you. Okay. Okay, fine then. So that is clear now. Okay. So usually that's the difference. So that's the doubt or whatever discussion usually students have. It's like I want to do design course, I want to do CAD course, or I want to get into analysis, I want to get into designing. Now people have these terms in their mind, but they don't know what exactly that means, isn't it? So all those things we'll be discussing today, and we'll be going specifically through automotive design. Okay. So now let me tell you what is the difference between automotive and automobile. Now automobile could be anything. Now say there's a bullock cart, even that is an automobile. Okay. You have your cars, your bikes, all those are considered as automobiles. But I can't take the entire plane as an automobile. Okay. But I can take that as automotive. Okay. So the automotive sector includes all of these things. So automotive sector is the larger one. Okay, it is a larger domain which includes automobiles as well. So automobile, as I told you now, it could be anything which has a power generation. It could be manual, it could be electrical, it could be any other source. Okay, like diesel, petrol, all those stuff. Okay, so beginning with your designing. So let us go from the base. Okay, from the scratch, we'll go from that. So first thing, as a design engineer or as a mechanical engineer, when you get into the design industry, you should know what is a product. Now tell me guys, what is a product? Type it in the chat box. Just tell me your basic definition of a product. What is a product? Or you can use your microphone as well. Just let me know what is a product according to you. So let me tell you, so in simple words, a product could be anything. Okay, a product could be anything that serves a purpose. Now you see, I'm using this particular screen. Okay, even this is a product. I'm using my microphone. Okay, my earphones. Even that is a product, isn't it? Now we are looking at the screen. I'm sitting on a chair. Everything is a product, correct? So product is anything that can be manufactured to serve some requirements, to serve some needs. Got it? So for a design engineer, if you're looking to design a particular product, you should know the basics of it. Okay, so how it starts. Now see, in the olden days there was no electricity, was it? Very long back, okay, there was no electricity. So there was a very strong necessity, there was a strong need for me to power the houses, or even the devices or the products that we have. So that is what led to the invention of electricity. I hope you guys know that there's a proverb called necessity is the mother of all inventions, isn't it? So that is how it starts. So let me just point it out here. I hope you can see this laser pointer on the screen. Okay. So the first thing for a product is the need. Okay. So that is what decides what your product is going to be. Correct? Okay. So I'll be deciding from the need. So let's say I want to make, I want a pen that I can write with ease. Okay, I don't want an ink pen, I don't want a gel pen. Okay, I need something that I can write it or anywhere. It could be a whiteboard marker, it could be written on the board as well, it could be written on the book as well. So even that is a new concept, isn't it? So it starts with a need. Okay, so from a strong necessity, then I'll be going with the concept. So that comes here in the ideation phase. So this is known as the ideation phase. Okay, so most of you won't be knowing. Say you'll be thinking, okay, I'll go become a design engineer, I'll become that and this, but you should understand the basic fundamentals of it. Okay, so for a product, this is the basic design cycle. So it starts with a strong need, then it goes for idea. Now in the ideation process, I'll be having lots of concept. Okay, let's say I'm the inventor of a mobile phone now, long back. Okay, now this idea, it won't come immediately to my mind. It would be like, some kind of concept in my brain. So I'll be like thinking, okay, what is, I need something that I can hold in my palm and I can operate it just like a computer, but it has to be very small. So this is a concept. Okay, long back. Now it's very, you're all familiar with it, but long back I'm talking. Okay, so I need something which has the computing power of a computer, but it should also have the compactness of my palm here. Okay, so that is the idea. So this is how the concepts begin. Then after that, I'll be doing the conceptual design. Now, what is conceptual design? Okay, so there are two things that you should know. One is drafting and one more is design. So what do you guys think? What is drafting? Can anyone answer? Have you guys heard of it? Drafting? Probably if you're a mechanical or automotive engineer, in your first year, you would have heard the term. You would have had a subject called CAD. Did you come across a term called drafting? What is drafting? Can anyone answer, please? Line drawing. Okay, anyone else? Good. So some people are interacting. That's good. Let's hope more of you interact now. Please interact. Do share what you know. Being a mechanic. Okay, drawing to be released for manufacturing. Okay, good. Correct. You're close to it. Accurate value of design. Okay, good. Those are very good definitions. Okay, so what happens is most of the people, they won't be knowing the difference between drawing, drafting and design. Okay, so let me make that clear to you now. See, now drawing could be anything. Okay, now drawing, I could just draw some rough sketch, I would call that as a drawing. Okay, now usually when you're in school or college, when you're free, you'll be scribbling something, right? If you want to just draw a car outer body or a bike outer body or anything, so that is drawing. Okay, now drawing, it's not necessary that it has to have any dimensions or any GD&T symbols. So drawing could be a rough sketch with any rough concept, but drafting has to be accurate. Got it now? So drafting has to be very accurate with all the dimension, with all the standards. Clear? Then comes the designing part. Now designing is basically 3D modeling. Okay, so what is 3D modeling? Now 3D modeling is creating your concept from scratch, giving material to it, giving dimensions to it in 3 dimensions. Drafting is purely 2D. Remember that. Okay, I hope now it's clear. So drafting is purely 2D. Okay, with the line diagrams. Okay, with the accurate dimensions. Okay, and that is considered as a final document. Now you go for an industry, you create a 3D model in any 3D modeling software, right? You'll be using either SolidWorks, CATIA, NXCAD, anything. You'll be using this 3D model to create whatever the product that you want. Now this product, I can't just bring it out of the system and give it to the vendor or to the client. Now can I? No, right? I have to print it out in some kind of medium, in some kind of material. So that would be the 2D draft. So that we call it as a document. an engineering drawing which includes all the dimensions and the standards and the detailed symbols, and we'll also be mentioning what is the material required, how much is the quantity, who has designed it, okay, who has supervised it, okay. All those things I'll be considering in an engineering drawing. Now this is very important because most of you won't be knowing. You thinking, see, when I become a design engineer, I'll be modeling so and so stuff, but it's not so cool and so, so easy. There is a step by step process in the industry, okay. Now let us imagine a scenario, okay. You guys are the client, okay. I am the designer at an industry, okay. You guys come at me and you give me a particular, product. You tell me this is the idea, I want it to be designed in so and so way. So I can't just walk around and just design it and give it to you. So there is a step by step design process that has to be followed, okay. First I will consult with my team, okay. There will be an R&D team. So what is R&D? Can you guys type it in the chat box? Let's see what is R&D. R&D.
Research and development.
Yes, very good, okay. It is called as research and development. So what do you think, what do people do there? Don't tell me the obvious word that they do research and development. Tell me something else. What do these people do?
They'll analyze the things like
Hmm?
it's people are not like
Correct.
that.
Okay, good. Then what else? Anything else apart from that? They're responsible for a lot of things. Let us see. Yeah, do answer,
Product is
please.
built from the scratch.
Okay, correct.
Product is built from the scratch to the prototype.
Okay,
Within that period,
good.
research and development has to be taken place to
Correct.
find a final product.
Okay, good. They upgrade and update the product. Okay, good. Then anyone else? Good answers you are giving. Very good. Okay, so what happens is, see, these research and development people, they're responsible for a lot of things because they are the main, designers, the drafters, the sketchers, okay, the idea creators, okay, all those things come into the research and development phase. Now, what happens here is, now if it's a new product, okay, so these guys are first going to analyze the market. Now let's say I'm taking a new motorcycle, okay. First they'll analyze now what is going on in the industry. Now you know what is happening. So there are stuff like electrical vehicles, okay. There are something like BS6, then there's something like hybrid vehicles. So what is happening? The market, the industry is changing, okay. But when the industry changes, now some of you might fear that my job would be lost. Now there are, some people would be fearing that there is no scope for so and so, there is no scope for mechanical, there is no scope for automotive, okay. The industry is changing, but it's not like that, okay. We are just upgrading ourselves, we are just upgrading the industry. So the people who are working in the operation, my voice is breaking out, is it audible now? Okay, I think somebody is having an issue. Please let me know if it's not clear, okay. If anybody is facing any technical issues, please let me know. Okay, fine then. Okay, so what happens is, see, the industry is upgrading itself, okay. Now these people in the production department or in the quality checking or in the operations department, okay, so these people, for them it's a little bit hard, okay. So what happens with the advent of new technology and automation, people in this particular sector might lose their job in future, okay. But someone in the design field would never lose their job because you want to create anything, okay. Let it be a small plastic toy to a actual car. We need design engineers everywhere, isn't it? Okay, so anything you want to design, we need design engineers, we need analysts, okay, we need drafters. So this particular field is evergreen, okay. It's not just in automotive I'm speaking in general, okay. So the scope of design engineers is everywhere. Even you, if you want to create an electrical circuit, you need a design engineer. If you want to create a small plastic utensil, okay, at home, even that is created using design, okay. All these things that you have in your kitchen, even that is from designing. All these models, this system, this keyboard, everything has to be created from scratch by design engineer, okay. So that is why this design engineer, this, the word design holds so much value in the entire world. You go for anything, not just mechanical I'm talking. You go for Photoshop, you go for, Illustrator, you go for any kind of design. So everywhere they mention design, graphic design, they mention mechanical design, civil design. Got it? So design, the word design itself holds so much power, Okay, so this is just an just a scenario. I'm just making you familiar with the present scenario, what is going on, so you don't have to worry about your jobs. So what happens, you just need to skill up yourself. Okay, you just need to skill up your design capabilities. Clear? Okay, now so let me get back to the PLM cycle. So it stands for product life cycle management. Now, as I told you, a product is something which has certain requirements. Okay, so this product I'll be using for my own purpose. So in order to design that particular product, I'll be going with the need first. So what is the need? What is the necessity? I'll be checking. Then I'll be going with the idea and the conceptual design. So then we came into the R&D department. As I told you, they'll first do the market research. Okay, based on the market research, based on the customer demand. Okay, based on the raw materials that is available. Okay, based on what people are looking for and what upgrade can I do. All these things are considered by the research and development. Then they'll start with the move. Okay, when they're starting, they'll not just directly go and design something. Even in the design process, there'll be first a lead sketcher. Okay, so he'll be drawing it. So he'll be drawing your, he's also called as a stylist. Even he'll be doing the first 2D, the first 2D draft of it. Okay, so he'll be drawing it. Then for that, he'll be doing the conceptual design. Conceptual design could be done using any 3D modeling software, or free from modeling also can be done. Okay, after that, you're going for 3D modeling. That is here. Look at the screen. It is called as a designing, or it is also known as 3D modeling. You would have come across that term, 3D modeling. Okay. Now, what is analysis? You tell me. What is analysis? Type it in the chat box. Let me see what you guys know. What is analysis? It's a very important term. Yeah. You can also talk directly, or you can use the chat box. What is analysis? Yes, please. Do interact. Okay, testing the FOS, factor of safety, good. Finding out, checking the product, good. Okay, so these are good terms. Okay, okay, good. So let me tell you what exactly. Okay, the pros and the cons. Yeah, good, correct. Okay, so these are general terms. What when it comes to your mind when you hear the term analysis. Now basically analysis comes under four things. Okay, one is structural. Okay, then is thermal, then is your pressure, then is your component interaction. Now if I take structural, it deals with all the stress, the strain, the bending moment. Okay, the torsion, all those things comes under structural. Then if you go for thermal, it comes with the temperature. Okay, 3D drawing. Okay, someone has typed 3D drawing. No, analysis is not 3D drawing. Okay, so analysis, that's what I'm telling. So it comes under structural, pressure, thermal, and component interaction. In structural, we had stress, strain, bending moment, torsion. All those things would come. Okay, moment of inertia. Okay, Young's modulus, everything. Then we have your temperature. In temperature, we'll see. Now let me take a product. Okay, so that you get the idea. Now imagine. Okay, I have a pen. Okay, now this pen, I bought it from a manufacturer. Okay, from the shop, I bought it. Now I'll take it to a very hot room. Okay, let's say it's a boiler room. Okay, where the temperature is, say, let's say 70 degree or something. Now the pen would melt there. Okay, immediately I'll go and complain to the shopkeeper, and then I would go to the manufacturer, like, what kind of pen have you given? But that manufacturer would tell me that I have already mentioned in the box, in the that slip that they give. Okay, all the product details, that they mention not to exceed 60 degree. Okay, so that is how they get this particular value. They'll be using analysis softwares for that. Okay, so they'll be getting the data of your analysis from this analysis softwares. So there are softwares like ANSYS, there are softwares like Hypermesh, ANSYS Fluent, MATLAB. All these softwares are there. Okay, so now let's say some manufacturer would tell that my engine, it works for, I mean, it would it would wear and tear after, let's say, 20 years. Okay, now that doesn't mean that they've kept the engine running for 20 years and then they'll come out with the result. No, they're going to run it immediately in a quick manner in your analysis software. Okay, so this is how it goes on. Manoj, you're having some issues with my voice. Voice is breaking. Do check your internet connection, please, because I'm not getting in the same response from anybody else. Try to sit in a place where there is good connection. Okay, Akshay also is having. Okay, anybody else facing the voice issue, please? The screen is visible. Okay, Everybody type yes if it's clearly audible. Just type yes. Let me just take a majority here. Okay, it's fine. Okay, okay, good. Okay, good. And if everybody is following, just type yes again. If nobody's, if you guys are facing any issues, just type no then. So let me just get that feedback also. Okay, good, good. So everybody is following also, right? Okay. If my pace is very fast, do let me know. I'm just going step by step. Okay. Any issues, you let me know throughout the session. Don't feel shy. Just be direct. Okay, whatever it is. Okay then. Fine. So we are going about the analysis part, isn't it? So that's how it goes on. Okay. See, suppose an engine is running for, they'll be telling that this engine has a lifelong, economic lifetime of around 20 years. So that's how they do it in the software. They will put the entire data of the software of the product. Okay. The engine, or let's say an engine, they're going to analyze it. Okay. They're going to run the timestamp and it runs for so many time, and then yeah, APDL, correct. Software for analysis. Yeah, ANSYS. APDL is a very basic software, but okay. See, in ANSYS, there comes three things. One is APDL, okay. One more is ANSYS Workbench. One more is ANSYS Fluent, okay. So if you guys, if you want to note it down, just take a pen and paper and note it down, okay. So there are three things: ANSYS APDL, ANSYS Workbench, and ANSYS Fluent. So what you learn in college is ANSYS APDL. So you'll be just taking some 2D lines, okay, you'll be putting some loads there, then calculating bending moment, okay, the structural strain, stress, then some thermal moment, all those things you'll be calculating. But in industry, these are very basic terms, okay. Nobody uses that on a large, on a large manner, okay. They'll be using ANSYS Workbench. Okay, so the ANSYS workbench would include things like static analysis, dynamic analysis, model analysis, thermal analysis. Okay, okay, there are a lot of stuff in that. Then we have ANSYS Fluent, where we have CFD. What is CFD? Let us see. What is CFD? Can you type the full form? CFD.
Computational fluid dynamics.
Yes, correct. Good, good. So, okay, so it stands for computational fluid dynamics. What happens there is we deal with the fluids. Clear? So, anyway, in depth, we'll be going on later on about all these topics. Okay, so let us come back to the actual PLM cycle here. So, I hope you got an idea now what is analysis. Okay, so it deals with all the various factors under varying conditions. If I take any product, I have to make sure that it runs, that is, I get data from it under varying conditions. Okay, like if the temperature is high, how will it react on my product? If the temperature is too low, how will it react? Okay, if there is, now let's say I'm using a mouse here. Okay, this is moving. Now if I put too much of hand pressure, it would break, isn't it? Even that has to be calculated, like how much hand pressure can it withstand. Okay, so all these things come under analysis. Next is your drafting. As I told you, drafting is one of the most important. Please repeat the types of analysis. Okay, so there are four things. For it's not the actual types, but in basic, so that you get it, I'm telling it. Okay, since you're a beginners into this, analysis is a very vast field. Okay, so basically there are four: structural, thermal, pressure, and component interaction. Okay, component interaction is basically your wear and tear. Now suppose, say, if you take an aircraft engine, there are millions of moving parts inside it. So what happens? Wear and tear happens. So that would immediately lead to friction. That will lead to heat creation, heat generation. Okay, so all these things would immediately bring down the economic lifelong, the life term of it. Got it? So all these things comes under analysis. So these are the basic terms I'm using. When you go to industry, a lot more technicalities come. Clear? Okay, you guys can note it down. Okay, yeah, good, good. So take a pen and paper also if you want to note it down. Okay then. So next we go for drafting. Now what is drafting? Drafting, as we discussed earlier, it is the 2D documentation. Okay, after your 3D modeling and analysis, I'll be making the 2D part of it. Okay, so that is your drafting. Next we go for prototype. So as we notice here, see, it would start from the need. Okay, then it will get the idea. Okay, like what is the concept. Then we'll be going with the conceptual design, a free form body design. After that, we'll be giving some dimensions and everything here in the design process. Then we'll be testing it out. Okay, I'll be testing under various conditions if it's good or not. It's not a continuous process. Okay, remember that. Most of you won't be knowing. You'll be thinking, okay, immediately I'll do concept, I'll be going for design, then I'll be going immediately to analysis. No, it's not so easy. If there is any fault or any errors found here in the analysis sector, okay, in this domain, I'll go back again to the design. So that's why analysis is done, so that if I found any faults, okay, or any errors or any dimension, or any, there'll be tolerances, okay, there'll be fits. So if there is any mismatch, I would have to go back and recreate it here. Okay, so after this is done here, again I'll do analysis. Again if it's again if there's an error, yeah, iterative process, good, okay, it's an iteration. So what happens, the same iteration has to be repeated unless I get the perfect product out of it. Because you see, being a manufacturer, you have to take a lot of risks. Okay, so if let's say I skip this step, okay, after the design I directly go and do manufacturing here. Look at the screen. After the design I skip this entire process and I directly go for manufacturing. Now what would happen? If the product is well designed, okay, fine, then okay, it would come out very good. But if it's not proper, the entire batch would be a waste. Now, as you know, manufacturer won't be producing just one product. He'll be creating thousands, lakhs and crores of product at a single time. Okay, so that's why we have here something called prototype. So the prototype is something after design, after analysis, after the 2D draft, then we go for the prototype. Prototype is one product, okay, one or a couple of products also they do. So that is to make sure that whatever I've designed is proper. Okay, so before me going into the actual batch production, I would create a prototype and then test it out. Okay, you might have heard of crash tests, okay, for cars. Then there are some, testing for products. So any product you take, they will be creating a prototype. Sometimes they also use it for marketing. Now you might have heard of Cybertruck. So which company owns Cybertruck and who's the owner of that company? It's a very, yeah, good, Tesla. Okay, and who's the entrepreneur there? Elon Musk, correct. Okay, so you guys should be updated with that. Okay, if you guys are not aware of it, search after the session Tesla and Elon Musk. Okay, it's a very inspiring story. Got it? So Cybertruck is also prototype. Only one or few prototypes they have created. Okay, now this prototype, so you can, if they are going to actually manufacture it by the year 2021, I think. Okay, so right now with the prototype itself, their marketing is so much. And when you're marketing your prototype, we'll also come to know of its drawbacks. People would tell, like for the Cybertruck, it got a lot of, lot of criticism that its design is very boring. It looks very, very blunt with all the corners and sharp corners and everything. But when you look at it from the design point of view, it's actually a designing marvel. Okay, so it will reduce all the drags and a lot of stuff. Anyway, in depth we'll be seeing that in our courses. Okay, we'll be taking models from that. Okay, for now if I go to depth, then I think it would extend for lots of hours. Okay, I hope whatever I'm telling is interesting. If it's boring, please let me know. If it's boring, type BOR. If it's interesting, type INT. Let us see. Okay, good. INT. Most of you are typing INT. Okay, good. Okay, good, very good. Yeah. Okay, so that's how, so any workshop or webinar should go on, so that you get knowledge with real practical examples. Okay, thank you. Okay, next we'll go for manufacturing. Okay, so design, analysis, drafting, so that is a prototype. So you can take the example of Cybertruck for a prototype, so that you can get a good idea what is a prototype. Okay, then we'll be going for the manufacturing. Now after the manufacturing, so all the batch production, everything is done, the product is ready. Then obviously marketing. Okay, so the main aim of any company is to do sales and marketing, right? They need to make money. So that is what here we have the marketing. Then we have feedback. Now tell me, why do we need feedback? Type it. Let's see, why do we need feedback? Why can't I just go and complete the cycle? Why do I need this particular term called as feedback? What is the importance? Yeah, answer. What is feedback? Now, as you noticed earlier, I asked your feedback about the session. So why did I do that? Yeah, satisfaction. Yeah, good. To know the drawbacks. Yeah, to know what are the benefits. Oh, okay, good. Okay, then okay, correct. Yeah, benefits. Not just benefits. It's also for the drawbacks. Yeah, and any corrections needed. Yeah, good, Mister. Okay. So what happens is from the feedback. Okay, so the main user of my product is the consumers or the customers. Okay, since they'll be using it on such a large basis for such a long time, I'll be getting the accurate feedback from them. Okay, if it's good, if any improvements are needed, or if there are lots of drawbacks. If there are lots of drawbacks, I would bring back the product. Now you might have heard in the news, sometimes you might have read some articles like, say, Maruti Suzuki is bringing back, it's calling back so many of its cars because of some error in its, let's say, bonnet, or some dicky problem or something, it's not closing, or there's some error. So that is the feedback from the customers. Okay, they would call it for free, then for that they'll again repeat the process. Even that process takes around 2 3 months. Okay, again they'll come here. Okay, an inspection team. Okay, so this is how it goes on in the industry. All right, now an inspection team would go to the product. Okay, they'll check the product from, they'll take photographs of it. Okay, now this particular photographs and all the this model itself would be given back to the designing team. Now expectation should be satisfied. Okay, good, Naveen Kumar. Yeah. Okay, so this product they're going to take it to the design team. Now they're going to analyze it again, like what is the error. Okay, now again they're going to redesign it, they're going to improve it. After that, they're not going to directly manufacture it, they're going to create a dummy of it, either using wood or some carbon fiber or anything. Okay, it could be anything. So there are a lot of other materials in, depending on the industry, what kind of product you have. Okay, they'll be creating a dummy product, then that particular product they're going to fix it to the original car. Then they're going to see if it works or not. If that is fine, so that is nothing but the prototype. Okay, if that is fine, then they are going for the actual manufacturing, and this small process itself would take around 2 3 months. Okay, so that's how it goes on in the industry. All right, now tell me, how long do you think it takes for a car, okay, for the entire concept of a car, from the scratch to the actual manufacturing? Can you tell me how long it takes? Can you guess? For any car, how long do you think? In general, how long do people or industries take? 4 years. Okay, good. Is it only 4 years? 3 years? Okay. Okay, depends on each industry. Okay, presently the years are getting reduced. Okay, with the technology and everything. Okay, with the advent of product cycle management and product data management, depends on the market placement of car. Okay, good. So in general, what this market analysts have given the data is, it generally, on an average, it is 3 years. Okay, on an average, but it depends on each specific industry and each specific brand also. Now some specific car manufacturers have automated everything, the entire process, apart from design. Okay, apart from design analysis and drafting, they have automated everything else, the manufacturing. So for them it would be much smaller, the duration would be much smaller, but for other brands it would be much higher. Okay, it depends. So on average it takes around 3 years. So the car that is launched in market today would have already been started around 2 3 years back. Okay, remember that. Got it? Okay, so that is the entire PLM cycle. Now I hope this basis makes a very good change in your fundamental knowledge. Okay, because this you should know. Most of them won't be telling you this. They'll be telling, okay, take up this software, do this. Okay, do SolidWorks. Your life as a design engineer is set. Do take up ANSYS. You'll be a very good analysis. No, but you should know what is the fundamentals, right? You go tomorrow to an industry, you don't know what is the difference between drafting and designing, they would kick you out. Okay, so you should know what is drafting, what is designing, what is analysis, what are the types of analysis, what is the prototype. Correct? And make sure you improve your communication every day. Okay, that is one thing I stress to my students or whoever I'm teaching. Okay, so no matter how much knowledge you have, unless you're able to portray it, unless you're able to tell to the other person, you won't be able to survive much longer in this particular domain. Because see, you may think that I'm a mechanical engineer and my job is just to create designs. Okay, but being a design engineer, you're responsible for the entire industry. Now let me give you a scenario. Okay, now you are the design engineer. Now what happens is, when a client comes up, okay, he is going to tell you that I need this to be designed with such a tolerance. Now tolerance is the minimum amount of accuracy that you're going to give, minimum or maximum. Now what happens is, your industry, it doesn't have the equipment to produce that particular product. Okay, now you're responsible to satisfy the client as well as your manufacturer. Okay, you're the company that you're working for. So that is the dilemma of a design engineer. You have to make sure that you know the entire industry. You should know what are the capabilities of your equipments. You should know what are the raw materials available, that you are going to procure. You should also know that the client is satisfied. So all these things ultimately comes to the designer. Okay, so you should have the knowledge of the materials. So this is very important. You should know what are the types of materials and what are the different stress and strain for that. Okay, so as a design engineer, remember today, if you want, you can note this down: stress and strain cycle. Okay, whatever the graphs you have, stress strain diagrams and the entire cycle of it, and the different materials, strength of materials, all these concepts are very very important for a design engineer. Okay, strength of materials and your stress and strain. Okay, clear. Next we'll move on to the next one. So let us begin. Okay, I think I took too much time with the basics. Okay, sorry for that, but I hope it was informational. Was it informational, guys? Okay, good, good. Okay, because your basics and your fundamentals has to be strong. Good. Yeah, thank you. Okay then. So we'll begin with the introduction to automotive design. Now, what do you mean by automotive design? As I told you earlier, see, automotive is the entire larger domain. Okay, automobiles are smaller parts of it. Okay, so automotive design is the process of developing the appearance and as well as the ergonomics. Okay, of motor vehicles, including automobiles, motorcycles, trucks, buses, coaches, vans, even aeroplanes. Even those come under the automotive sector. Got it? Now tell me, what is ergonomics? Let us see how many people of you know this ergonomics. Don't search it up, just type it. What is ergonomics? Not many would be knowing, but good. Driver's comfort, very good, very good. Bravo. Okay, driver's comfort, good. So it's not just the driver, all the passengers inside it. Okay, so obviously that would include the driver, and it's see, there are two types of ergonomics. Okay, one is with respect to the passengers, one more is with respect to the actual body of the automobile. Even that is considered as ergonomics. Okay, it would decide. See, now you might have noticed that the sports cars are very short in height, but if you take let's say a sports utility vehicle, SUV, okay, that is much larger. Like if you take Hummer or if you take Pajero, so all those things, they have much bigger height because it depends on the terrain that they have used. Okay, now sports car, it has to move fast, isn't it? It has to reduce the drag. So that's why based on that the designing will change. Okay, so that is what decides the ergonomics. It is both the driver's comfort as well as the entire exteriors and the design of the automobile. Okay, now let us move on to the next one. Now there are different segments of cars, isn't it? You can have a look at the screen now. So we have micro, sedan, CUV, SUV. What is CUV? Can you tell me? Can anyone tell what is CUV? Let's see. Okay, it is crossover utility vehicle. Yeah, correct. Okay, somebody has typed Akshay. Okay, crossover utility vehicle. Okay, so what happens is, basically it would be a crossover between your SUV and a hatchback. Okay, now you can notice the design here. Look at the design. See, it is a crossover between your SUV and hatchback, and in some terms it depends on other models as well. Sometimes SUV and coupe also they'll do. Okay, it depends. So it's nothing but a crossover. You can notice how it's different. See here. Okay, got it. Now we have roadster, pickup, van. So these are the different segments of cars. Okay, there's a supercar. See, there's a coupe, there's a camper van, mini truck, we have minivan. Okay, cabriolet, then we have truck, big truck. There are a lot more other segments as well. So this is a general segment of cars. So each particular segment of car would depend on the requirement. Okay, depending on the customer requirement and what kind of purpose it serves. Got it? Okay, let us move on now. Now this, note it down. If you want, you can take a screenshot of also of this particular screen. This is very very important. Okay, automotive trims. Okay, if you go to the industry, if you are very specifically interested in the automotive industry, these particular terms, okay, these particular terms BIW and trims are very very important. If you want, you can take a screenshot of this, I don't mind. Okay, now what happens in BIW and trims? Okay, now as you can read, body in white. So body in white would deal with the entire frame of your car or an automobile. So in olden, if you take huge trucks, okay, they would have a strong base. Okay, a strong base metal frame. Okay, even in the olden times, when these cars were made, they used to have it like that. They used to have a very strong rigid base frame which would hold the entire load. You can see on the screen, entire load of the automobile. Okay, but now what they've done is they've integrated the entire thing. This is called as a monocoque design. Okay, they've integrated the entire structure into one particular frame. Okay, so usually they'll be using different kinds of materials. They'll be using aluminum for this. Okay, and at some parts they'll be using hardened steel, and other parts of aluminum they'll be using some special molds of aluminums as well. So but generally they'll be using aluminum. Why do you think they'll be using aluminum instead of steel? Can someone tell why is it aluminum preferred? They also use carbon fiber. Why do you think aluminum and carbon fibers are preferred more? Yeah, someone is answering.
Lightest
Lightweight.
materials are aluminum.
Yeah, correct. Okay, the weight and also its strength. It's not just the lightweight, it's also about the strength. Okay, for the given weight, yeah, it can easily mold. Very good, very good. Okay, so what happens is, yeah, constraints, good. Okay, so what happens with steel, I can go with steel, but it would make my entire design very heavy. Okay, with respect to the strength, no matter, it's a very good material. Okay, so what happens is with aluminium, it's a very lighter material, as well as it helps me mold it in a much better shapes. Okay, the sometimes there'll be very complex design. If you take surface modeling, some particular shape, some particular, so like, let's say in the body frame or in the main frame or the bonnet, okay, or in the dashboard, there are some parts that I have to integrate very complex shapes. So it's very hard with some materials. So that's why we'll be going with aluminum and carbon fiber. So these are very much trending, and even there are advancements in that also. They're trying to blend it with other materials as well to make alloys out of it. Got it? Okay, so body in white is this particular thing what you can see. And why do you think they named it as body in white? Okay, can you tell me? If someone can tell me why they have used this white, then I can imagine that that guy has a very good knowledge in automotive. Why do you think they've used white? Nobody really discusses about this, but I would like to go much depth into these kinds of matters. Tell me why it is white. You guys can search also. I don't mind. It is very interesting actually. The name white. It actually deals with long back. Okay, so I'll just give you a brief. You have to search it later. I'm not going to tell what they were using. Okay, so long back. See, if you have noticed, even in these garages. Okay, in garages and all. So before painting, okay, before painting your body, they would give some white coating. Okay, some chemical they'll be using for that. Okay, so that is why it is called as white. So in long back, now it's not followed, but long back, when all this car manufacturing or automobile manufacturing used to happen, when they used to create these body frames. Okay, so before the paint could be absorbed into the metal, okay, before there's a covenant, there used to be a specific coating given, which used to give that white appearance to that. That is why its name got as body in white. Clear? So remember, if some this is just an interesting fact I shared with you. Okay, so that you know what is body in white. Okay, so body in white is it's like a history of it. Okay, so some past history of automobiles. So that's why it has got that name. So just an interesting fact. Okay, next we'll go with trims. Now what is trims? So all the aesthetic and non-visible parts are called as trims. Now I think the term itself is self-explanatory. Okay, so what is non-visible parts? Okay, aesthetic and non-visible parts. So that is with respect to interior trims and exterior trims. Okay, now see, other than engine and transmission, we have parts that we see inside the car, that is categorized as interior trims. Parts that we see outside the car as, yeah, it has to be exterior. Here there's a small mistake here, it has to be exterior. Okay, so exterior are whatever are on the outside, interior is within inside. Okay, now what happens is when you go to the automotive industry, okay, so usually the designations are like this: GET, then there's junior design engineer, associate engineer. Okay, like that. So if you're going specifically as a higher rank, you would be termed as a interior trim. Okay, so you'll be given that particular department. Okay, a design engineer for interior trims. Okay, or you may be working in exterior trims. So your job specifically, if you go for interior, you would be inside the dashboard or all the electronic parts that you have, how you're going to fit it. Because you see, designing is, when it comes to design, it's not just creating a product. It is also, you're also responsible for creating feasible products. Okay, you're going to be responsible for making the design as feasible and as economical as possible. That is the true quality of a design engineer. Okay, so that's, it's not like, see, some anybody can, give a few years or few months and learn a particular software, but that doesn't mean he's very good at designing. Designing, your fundamentals should be strong, your basics should be strong. You should know what are the, limitations, what are the different factors that I need to put into when I'm designing something. Okay, so that is very important, being a design engineer, being a very good design engineer. Got it? Okay, we'll move on. Now we have stages in design process. Let us see what are the different stages. Now we could start from product planning, then we have package data, we have concept generation and theme selection, student engineering and tape drawing. Okay, then we'll go from forms exploration, conceptual data, all these things we'll be covering. Okay, so today we'll be covering half of it, tomorrow we'll be going with the rest of it. Okay, tomorrow I'll also give you a demo about, about various softwares that are used in the industry. I'll just show you the interfaces and some models. I'll show it to you, like how it goes on. Okay, so that you get a very good idea about it. Clear? Okay, now what is product planning and brief? Now what happens, as I told you, this is the specific job of your R&D department. Okay, so they are carried out by multidisciplinary team, so it won't be just design engineers. There'll be market analysts, there'll be the CEO also sometimes. Okay, there'll be other, like the vendors, the clients, the procurement, all these people involved in that also. People from the floor shop, even those will be consulted. Okay, there'll be, team leaders for that. Now suppose someone who's a team leader of the floor shop, he'll be there. Someone who's a team leader of the vendors, he'll be there. Okay, someone who's a team leader of all the design engineers, even he'll be there. So all those things, they are the main people responsible to establish the parameters and decision points for any product. If it's a new product, okay, if it's a new product, it is called as an invention. Okay, but usually in the market, what is going on, it is reverse engineering is going. Okay, so what is reverse engineering? What is reverse engineering? Can someone give me a small definition? What is reverse engineering? Let us see. Yeah, do answer please. What is reverse engineering? What do you think it is? It's a very important concept. You can Google up, I don't mind really. Okay, the main intention of this workshop is you should learn something and you should upskill yourself in your own careers. Okay, yeah, what is reverse engineering? Can someone type? It's not going in reverse, don't tell me that. Yeah, someone, you can type also, I don't mind. If it's wrong, it's okay. Taking the ideal product and rebuilding it from scratch. Okay, okay, rebuilding it from scratch. Okay, why would I rebuild the same product again? Okay, so it is, okay, basically let me give you a, okay, let me give a brief about it. So what happens is, reverse engineering is something, you take a product. Okay, now let me take a simple mobile phone only. Okay, I'll take your mobile phone. Okay, now there are millions of different types of mobile phones, but the purpose ultimately, it is the same. One of the most important stuff is your calling and your internet and all other apps and other, all other computing and computing functions of it. Okay, but the main purpose is same, but why are there so many of them? So that is what you take in reverse engineering. You might have seen, like, say, some Chinese brands, they take, they copy the functions from some other US brands, or some Indian brands also copy. So it's like, everything is reverse engineering. So in the market, right now at present, inventions are very less. Got it? So if some brand or some company invents a new technology, yeah, good, copying, yeah, so everybody else starts copying that. So what you do, you take a product, you break it apart, you take its components, and you try, to change it little bit, so that you're not called a copycat. That's all. But ultimately you are. The thing is, either you can come up with a new invention from that, or you can improvise it. So it's a very, it's a very not a good topic that people they want to blamed upon. Like some companies tell, no, no, I've not copied. Like, because sometimes what should be going on, if you have seen, So there will be sometimes wars between Apple and Xiaomi. Then there'll be wars between Indian brands and some foreign brands, Samsung and Apple. All those things would be happening. They'll be telling that we have patented it, but still you have copied that. So all these things happen in the industry. Okay, so these are all huge corporations I'm talking about. But on local level, you know what are China products, right? So yeah, it actually means R&D process. Yeah, yeah. So it comes in R&D. Okay, reverse engineering. So it's a very important term. Okay, so it's a very important term in R&D. Now what happens is, so these people they're going to, so that's what I'm telling. So inventions are very less in the present scenario. Reverse engineering is more. People take a product, they'll just add. Now you might have seen, say, if I just take a toothbrush, okay, there are so many types of toothbrush. Now there are some will tell we have extra grips, we have some extra, tongue cleaners, we have that, we have this, we have flexible toothbrushes. So what do you think? This is also reverse engineering. They're just marketing it in a better way that people would buy. So consumers obviously they would get impressed with a good marketing strategy, isn't it? They would think, oh, it has a very flexible, movement. It has strong cleaners. It has such, some people would be having some cap also. They'll be like, oh, it has this and this. So these things come as part of reverse engineering and R&D. Okay, so I'm giving these examples so that you get to know. You can go with some engine, then there are pistons and cylinders, but these general real life examples make you understand the concepts. Okay, so this is what reverse engineering means. So in the present market scenario, inventions are less, but reverse engineering is more. Got it? Okay. So that is what goes on in the product planning. It could be a new invention. It could be reverse engineering. Okay. It could be market needs and the type of. So all these things are analyzed. The needs of the market and the customers. Okay. Designers. Like what is the design brief and what is the different positions of the new vehicle. Now, if I'm making this car for people who are into sports, okay, then the design would change. If I'm making it for families, then it would change. If I'm making it for luxury, then it would change. If I'm making it for limousine, so it is for parties and huge celebrities and all. So that would change depending on that. So I would make the design based on the market research, based on the customer need, based on all these factors. So that comes in the first step. Next, we have package data. Now, what happens in package data? Okay, so it is a balance between product design, engineering, and manufacturing alternatives. Now, here is where I'm going to decide what particular concept or what particular engineering or mathematics I'm going to use later on. Okay, now there is also something called your benchmarking. Now, what is benchmarking? Okay, if you guys don't know, benchmarking is something. Now it's a setting a standard. Okay, benchmarking would be available in the same company also. It is also available between competitions. Now let's say Kia Motors, you might have heard of Kia Motors, right? Now let's say they have launched a new car into the market. Now that becomes a standard. Okay, now what these people, now what this Maruti Suzuki or Tata would do, yeah, good, setting standards. Okay, so now what they would do, they would keep that as a standard. The, let's say, the new latest range of Kia Motors, okay, that particular car they'll keep it as standard, and they're going to try to build something even better than that. Okay, so that is what benchmarking means. The benchmarking is setting standards between competitions as well as with your own products. Now let's say Tata Motors has a latest car. Okay, now this car, for the next time they're going to try to build it even better. Okay, so that is what benchmarking means. It could be within your own company and with the competition as well. Got it? So all these concepts are covered in the package data. Okay, also architecture and developing theme specific feasibility. Theme in the sense the colors, the contrast, okay, what kind of texture it has, all those stuff. Next, so let me take a break. Can you guys tell me, are you following with whatever I'm telling? Any issues you're facing? Any issues with my pace? Any issues with my accent? Anything? Okay. Okay, good. Okay. Okay then. So again, I would repeat it again. So if it's interesting, please type int, so that I get a good feedback from you guys. Or else if it's not interesting, I would try to make it more interesting. Okay, type in int. Yeah, good. Okay then, fine. Okay. Okay, let me try to get. Is it breaking? My voice is breaking. Okay, now is it audible? Okay, fine. I think it's better now. Okay, let me just. Okay, fine then. So what do you guys aspire to become? You want to become, you want to go into which sector? Can you let me know? Let me see what you guys want to become. You want to become good automotive, you want to go into automotive, aerospace? Type it, let's see, so that I get a good idea. Everybody is interested in going into automotive, automotive industrial design. Okay, then let us see your opinions and your dreams. Automotive, then everybody is interested in automotive. Good, good. So all are automotive enthusiasts. Yeah, yeah. Oh, very good. Hmm. Design engineer. Okay, design engineer. Okay, design engineer, it could be in any field. Okay, you go for electrical, you can go for any field. It's not like limited to auto. Okay, some are interested in automation also. Very good. That's a very good field. Automation. Good. Okay then. Fine. We'll continue. Now there is something called concept generation and theme selection. Now as you can see, based on the picture that I have shown here, okay, here I am going to select what kind of body my car has. Okay, and what kind of colors that I'm going to choose, and what kind of surface design that I'm going to do for this. Okay, this is very very important. Now there is something called, okay, there are two phases: concept phase, sketching and ideation phase. Okay, now here in the concept, designers put their ideas for exterior and interior of the new vehicle. Now as you can see, so basically, see, if you're scribbling something or doodling something on a piece of paper, you would start with some kind of design. Okay, and you would try to tell your friends, okay, look at my design, this is very cool. So I would try to make something like this. Okay, so this is nothing but the concept phase. It goes the same with your industries also. There will be a lead stylist. Now the stylist is responsible for drawing the first sketch. Okay, he'll be drawing with his hands or using a, a software also. For that he'll be using some kind of tool. Stylist also they will be using. Then for that particular drawing, they are going to then convert it into 3D. Okay, so this is the first part of it. He'll be deciding the outer body of it. So this is known as the giving the class A surface finish. Now this term is very important. You can search it after this: class A surface finish. Now even in surface finishing, voice is breaking. Now is it audible? Okay, is it audible now? Is it audible now? Is it clear now? It's completely breaking. Frequent, it's breaking. Okay. Okay. Check now. Now it's clear. Okay. Okay. Fine then. Okay. Okay, sir. We'll continue then. Okay. So in the concept phase, see, there's something called class A surface finish. Now, what do you mean by class A? See now, video audio is clear, not video. Video is static. Video I have not moved it. Hmm. The video is not clear because video I have kept it as static. Video is not moving actually. So you can see the pointer, right? Okay. 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 It's clear. Okay. Fine. Got it. Okay. So there is something called class A surface finish. Okay. So what do you mean by class A? See, there are other classes also. There is class C, there is class B, there is class A. Now the smoothest degree of surface finish is class A. Now you can see when you create some automobile, the surface has to be tangential at every point. Okay. So if I start, if I shouldn't be getting any bumps here. So if I go like this, if I just pass my hand over this smooth surface, it should just slide, okay, smoothly. So that is what I'm supposed to achieve. Okay, it is the holy grail of surfacing. So it is called as class A surface finish. It is the highest degree of surface finish that you can give, be it automotive, be it aerospace, okay, or any specific industry that you go into. So even in class A, there are something called G1, G2, G3. Okay, you search these terms. There is something called G1 continuous, G2 continuous, okay, G3. So these are all the types of surface finishing that you can give, like how smooth it is. Okay, it decides the degree of smoothness. So all those things would come here: sketching and ideation phase. Okay, this was the concept. Then we go for the sketching and ideation phase. Here we'll be having informal selection of concept sketches and management. okay, review of concept sketches, okay. Then that is after all the reviews. So there will not be just one stylist, there will be multiple departments, okay. From all the feedbacks, from all the data that they have drawn, okay, whatever the sketches they have drawn, from that the best would be selected, and then it would be continued for the next process. Clear? Next, now we go for the exterior design. As I told you earlier, see, so these kind of sketches would be done. You might have seen this even among your friends. You might have some, some of your friends who do these things very well. Okay, there are very passionate people. They will be doing this kind of sketches right from beginning. Okay, so this is called as the exterior design. Okay, in industrial design also it is called. Okay, so for automobiles they will be going with these kinds of sketches. So the main role of a stylist would be doing this. Okay, will be creating such sketches, then we'll be going on with the actual class A surface finish. Okay, now this was exterior designing. Begins with your inspiration and becomes a sketch design. Designers create sketches, okay, using both manual and electronic techniques. As I told you, people sometimes would be drawing it manually, then there are other softwares also. It depends on what mode you use. Clear? All right, next. Now for exterior design, what are the different things? Now you can see this is somewhat like a cyber truck, isn't it? It's somewhat resembles that. Okay, see, if I'd gone with this particular model, okay, let's say in my industry I have one designer or one stylist who has created this, another has created this. Now tell me, whom would you go with? You would go with number one or number two? Type it in the comment box. Let's see. You would go with one or two? Okay, now that you're told two, why would you go with two? Can you tell me why would you go with two? What is the reason? Yeah, what is the reason? Aerodynamics, market needs, stylish, then what else? Okay, you tell me now, the appearance of a car is important or not? Yes or no? The appearance of a car, yeah, important, correct. Okay, because that is the first thing you'll notice, right? See, if you go for a showroom, immediately you get connected with the car looking at the appearance, first of all, isn't it? No matter how powerful the engine is or no matter how good the mileage is, at the first instance, the first impression that a car makes is from its appearance, correct? Yeah. So then comes your aerodynamic and everything. Okay, this comes from the designer's point of view. But from a customer's point of view, at the first instance, it would be appearance, the colors, the textures, okay, the types of wheels, the types of, the trims, interior trims, exterior trims, the interiors of that, the kind of leather it's used, okay, the kind of engine it has. That all comes later on, the technical terms. So it depends. So initially it would be the appearance, then you'd go with the its horsepower or whatever, its output, its mileage, okay, and its lifelong term, and all those things would be coming later on. So appearances play a very very important role in order for a car to be appealing to the people, to the customers. Got it? Now if I had done here, and now let us go into the design parts of it. Okay, design aspects. Now see, if I have this model, okay, if I have this particular model, the air would be passing it here. Okay, now there will be a very strong resistance on this windshield. Okay, so it would ultimately, okay, decrease the speed of this car. But if it's like this, it would shear through, it would depend on the smoothness of this outer body, and it would just pass it around. So drag would still be there. It's not like it's going to be zero, but it's going to be very less. Okay, here, so it would be very less here, but here it would be very large. Okay, so these minor things may seem, from the appearance wise, it may not seem too much. Okay, this is a little bit boring, but this is a little bit stylish. But when it comes to design and the aerodynamics, it is very very important. See, you can see here, see, look at the cuts here, look at here. Okay, look at the outer cut here. Okay, see here, so it's a blunt edge, here it's a sharp one, so it will shear through the air. Okay, look at here also, even when the air is passing by you, even here the drags would be created at these portions. Okay, so these minor design changes matter a lot. Got it? So that is how you should learn. So as a design engineer, you don't just create things as you wish, you create that are feasible and that really gives extreme or beautiful results, okay, from your designs. Got it? Now, so as I told you, group of sketches, and we have design management. We'll be using rendering tools, then design ideas, okay, from the feedback from the management and the marketing team. Everything I'll be considering, then I'll be creating the model. Next. Next, we have studio engineering and tape design. Now, what is this? Now, here is where I start with the softwares. Okay, after the design, everything is finalized. Okay, the basic design, then I'll be going with the softwares. Now, here I'll be starting with the from the 2D lines only. I'll be creating the surface design. Okay, into 3D I'll be going. Now there'll be different softwares, CATIA, NXCAD. So these are very much used for surface design. Okay, so if you're very much interested into car surfacing and stuff, you should learn CATIA and NXCAD. So these are very advanced softwares that are used in MNCs. They're used in automobile industry, aerospace industry. Companies like BMW, Mercedes, Rolls Royce, they'll be using such advanced softwares. Okay, next. Next, we'll go with form exploration. Now, what are form explorations? Form explorations is with respect to the design of it. Okay. Now, see, as I told you, from the 2D sketch, I'll be converting it into class A surface. Okay, all these things. So these are the form exploration that I'll be doing here. Okay. So you can see development of mathematical curves which are evaluated for smoothness and continuity. As I told you, G1 continuity, G2, G3, all those comes here. Okay, so I have to make sure that the surface is as smooth as possible. There shouldn't be even a small bump on it. Okay, so even in the testing phase, if I found some even a small, even if a small degree of bump, I'm going to reject it immediately. Okay, so that's how important your class A surface is in the designing environment. Got it? Okay, so we'll go with the next one. We have conceptual development here. Okay, conceptual data development and all those stuff. Okay, now we have CAD software package, CATIA. So here it's not just CATIA, we'll be using lots of software. SolidWorks, we also have NXCAD, we also have Creo. Okay, now when it comes to this, we have something called vehicle type, main dimensions, styling, packaging, ergonomics. So all these factors matter a lot, okay, into determining what kind of data and what kind of model I'm creating. Okay, now we have mirror, tires, wheels that are developed and added to the CAD data. Now what happens is, this data first I'll make sure that these data are ready. After that I consider, like, from the all the various teams. See, there'll be teams for wheels, there'll be teams for the mirrors, there'll be teams for the doors. Okay, so there are separate teams for each of them. As I told you earlier, there'll be BIW, there'll be interior teams and exterior teams. Even within that, you'll be responsible. Some two people will be responsible for the door, some people would be responsible for the knobs, some people would be responsible for the gearbox. Okay, it's like that. It's not that they're going to give you an entire car to develop. That never happens. Okay, so it is segregated, it is categorized between people, between different professionals. Got it? So all this data is first managed and then we started. Next we go for clay modeling. So after all this design has been set, each product has been done, okay, everything has been assembled, we go for clay modeling. In India, as per Indian brands, we have Tata that has such a technology. Okay, then we have other brands from other countries that have their plants here in India, even they have such technology. Okay, now this is the process that transforms the 3D model into the actual clay model. Okay, so as I told you, we have to first create a prototype. Okay, so before the prototype, this is something called a clay model. Okay, sometimes, all right, so sometimes it is a smaller model, sometimes it's of the actual size. It depends on the professional that use it. Sometimes first they'll be going with a smaller model. Okay, so after that they'll be going with the actual size of it. Sometimes the sizes may range one fifth of it. Okay, or sometimes it would be created using the actual size of it, so that they get the data from the actual car model before even manufacturing it. Got it? So there's something called Dinox fill that is applied all over the clay model for better light reflection, so that it gives you that real car look. Okay, it's as if you created the actual model, and you can have a look at its design and various considerations. Okay, various aspects, various colors, various textures, and the types of wheels, and the types of bonnet, and the types of trims, and the types of arrangements of different models that you've done that. Got it? So that is why we do clay modeling first, so that if there is any error or any faults in it, I can rectify it later on, so that I don't spend so much of raw material and energy and expenses into that. Got it? Next is something called product ID. Okay, now what is product ID? As you can see, three logos we have. So what are these three logos? I think Mercedes and BMW, you can tell. What is the third logo? Can you tell me? Don't tell it as Rolls Royce. It's not Rolls Royce. What is that third logo? Okay, Bentley. Correct. Okay. Yeah, it is of Bentley. So now what are these? So these are the unique brand logos, okay, or brand icons or IDs that you can call. Okay, so these represent a particular brand. Even to give a specific logo, okay, or a specific brand image, for that there is a specific team. Okay, it's not just something I'll design and I'll put it as my car brand. No, even for this small logo design there are teams, multiple teams that will be considering. They'll be taking, the company culture, the country that they have, all those things into consideration, and they'll try to make it as unique as possible. Got it? So that is known as product ID or product identity studio also it's called. Next we'll see colors and trims. Now, the Color and Trim Studio is responsible for the research, design, and development of all interior and exterior colors. Got it? Now, see in industry, now you may be knowing a few colors. Let's say a maximum of 15 colors or 20 colors. But in industry, there are thousands of colors, 10,000s of colors. Okay, if you go actually, if you know about Rolls Royce, they have a specific bundle of colors. So they customize their cars actually. If you research properly on the topics, their each of their cars is very much known for their customization towards the client. Okay, so they have a very huge amount of colors. It's in the range of 10,000s if I'm not wrong. Okay, so in industry each color would have some pattern. Yeah, 30,000. Yeah, they're up to 30,000 also. Good, good. So it depends on each industry. So each particular industry would have a particular range of colors. So we will be knowing around say 15 or 20 colors max. But in the industry each color pattern would have a specific code, and like only if the client is okay with it, okay, or the customers are okay, they'll be associating the color with a particular emotion. Now if they take red and bright, that has a particular emotion. If they take yellow and sunny, that has a particular emotion. So they'll try to make that which color is more connecting to the people, which is more appealing, and that to which segment of the people. Okay, let's say if I'm making an adventurous car, I would choose a different color. If I'm making something as a family car like a hatchback, I would choose a different color. Okay, so it depends on the market research, the customer requirement. Okay, all those things make a very important factor into choosing the colors, and that too for the interior and the exteriors. It's not going to be one same color they're going to keep. Okay, there'll be multiple of color. They'll be choosing it based on all this research and all the requirements. Got it? So even that is a very important aspect. Colors and trims. Next we have the prototype. So after everything has been given, all the colors and everything, we creating the prototype. Now we can see there are wooden prototypes, there are clay models, there are carbon fibers also. Okay, so these are cheaper levels of carbon fibers, not the actual ones. So it depends on each industry. So it depends on people. So they'll be starting from the scratch. Okay, then they'll be assembling it all the various components. They'll be getting it here. Okay, so these are the various images we have taken, so that you get to know what are the different types of prototypes and what are the different types of modeling that is used to create that. Got it? So these are made, as I told you earlier, why prototype is done, so that before manufacturing I get to know all the various aspects of it. Can it withstand the particular load, so that I don't fail, so that I don't face any failure later on. Okay, when I'm creating like crores of batches, I don't face any failures or any errors over there, so that I do it in your prototype. Next we have design evaluation. Now what is design evaluation? I mean, design evaluation, I'm going to analyze it. Okay, now here if you can see, can you tell me what is this technology? What is the name for this? What do you call this? There are two terms. Let us see what you're going to use. What do you call that? Here, look at the screen. I'm showing it here. VR. Okay, what is the full form of it? Okay, virtual reality. But is it virtual reality that they are using? Virtual reality would mean creating your own virtual environment, but they're interacting with the car here. So what do you think it is? They're interacting with the car and they're analyzing. So that is not VR. That is something else. It starts with A. No, not horoscope. What is that horoscope? Horoscope is something else. What is? Have you heard of AR? What is AR? Type in the full form. What is AR? Nobody knows.
Augmented reality.
Yeah, correct. Okay, it is augmented reality. Now, what we do in augmented reality is we combine real life technology into your virtual thing. Okay, so what happens is I can analyze how these surfaces react to various loads, and if there are any abnormalities on the surface, okay, any deformations, all those things I can see in your augmented reality. Okay, in virtual conditions I can see. So that is what augmented reality means. It's a interaction between technology and real life. Got it? So that is how advanced technologies have improved now. So full size exterior and interior models and drawing are evaluated. Got it? And public attitudes are also considered. As I told you, sometimes brands would be marketing their prototypes to the industry. So there'll be exhibitions, right? You might have heard of various exhibitions. So when you're doing that, people would flock up from all the various countries and all. So if your prototype is very much impressive, it creates a emotion with the people over there, present over there. Then it would catch up like fire. So it would go from news channels, it would grow from automotive enthusiasts. Then there are promoters on YouTube channels. Those would give you that brand recognition. So based on that prototype only, you are going to build the, sometimes they're also going to use that as a reason for funding. Okay, so if a prototype makes a very good impact in the market, you're going to get a very good funding. If it's an IPO, that is, if you have a, you know in the public markets, if you have in the stock market you have a IPO, then in that case even that would attract lots of fundings from people. Because if a prototype is very successful at an exhibition, all the investors from all around the world, they would start investing. Okay, so all these things are technical aspects. I'm just giving you an idea what happens. Okay, next. Next is styling freeze. Now, as I told you, all everything has been done until this particular stage. So the prototype is ready, that means everything is done. So you're starting from your design. So what kind of design you have, what kind of exterior trims you have, interior trims you have, what kind of colors has been done. As I told you, colors has been chosen. Okay, the wheels, alloys, whatever, the mirrors, okay, the bumpers, the headlights, everything has been done. The logo also is done. Finally it is styling phase. So that means beyond this point I'm not able to change it. Okay, the body style and mechanical specification are finalized. So until this point I have to finalize everything. Major changes in the sheet metal mechanical components are very expensive beyond this stage. So that is why at this particular stage I will finalize all those things. So remember this term, styling phase. Got it? Next. Next we have design quality assurance. So after the freezing of it, then I'm going to start with the testing of the quality. Like what kind of quality, like how my design is. Okay, the design, as I told you, analysis softwares will be using. So we'll be using softwares like Hypermesh, we'll be using ANSYS. Okay, in analysis there is something called pre-processing, solver, and post-processing. Can someone tell me what is that? Pre-processing, solver, and post-processing, under which concept it comes? You might have studied that in engineering.
In pre-processing, we do meshing and again
Good, good, good.
geometry,
Have you heard of discretization?
and engineering data and all.
Correct, correct,
So in post-processing, we are like analysis works.
correct. What about
The result.
solver?
Uh,
Good, good, good that you're telling. Okay, so in pre-processing, obviously it would include all the initial stages. Okay, so analyzing it. Okay, so it would be like meshing, discretization. You heard of finite elements, finite element methods?
Yes.
Yeah, so that would come in that. Okay, so finite element methods is the whole sector of that whole domain. Under that we have all those things. There is something called FEA also. Okay, so solver will be solving with all the various mathematical equations and data. Post processing will be generating reports, will be generating the results from that. Got it? So if you have heard of Hypermesh, that is purely a pre-processing software. But ANSYS, it is a pre-processing, solver, as well as post-processing. It has all three. Got it? So just a small fact, a small interesting information for you guys. Got it? Now, so in the qualities, I'm going to do all the stuff. I'm going to analyze it. I'm going to check the models. I'm going to check the various. Can you guys please mute the audio? Please mute it because it's creating some disturbances. Yeah. Okay. Please mute it. I think somebody's audio is still on. Okay. So all the quality assurance and design calculations and everything will be checked in this particular stage. Next. Now we have prototype testing. You might have heard of crash tests. Now what are crash tests? Tell me what is crash test? This is very easy. Tell me. What do we do in crash test?
Testing the sustainability of the product.
Okay. Correct. Anything else? Safety testing. Okay. Good. Okay. Of passengers. Very good. Model scan. Okay. Stability of the product. Okay. Good. 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 Okay, so it would involve everything. Okay, it is not just about the car, it would be about the passengers sitting inside as well. Okay, so it would take all kinds of testing. It would be front collision, it would be from the side, it would be from the top. Okay, so they're going to test various factors, lots of things. So they'll be, look at the screen, so there'll be sensors placed on the body as well as on these walls. Okay, these are all sensitive. Okay, it is connected to the measuring tools. Okay, as you hit, the impact will be measured here immediately. Okay, how much is the force and the reaction from that, and also the deployment of your airbags, not just here, even in the back seats and even here in the sides. Okay, so this is just a brief I'm giving. So in depth there's a lot of stuff. Okay, so your design evaluation would be done using prototype testing. As I told you, before manufacturing I'm going to do all of these things, because after manufacturing all of my money and all of my energy and all of my equipment, raw materials have been already been given, isn't it? So that is why I make sure my prototype is ready for everything, then only I'm going for manufacturing. What it? So all these things would be analyzed and tested here in real life. Okay, so there are various standards for crash testing also in Indian, also Indian, we also we have European, also have, we have international standards, various standards we have. Okay, next. So you can check, you can Google up for any car you take, you can check the star ratings. Okay, so each particular standards would give you a certain amount of stars. So based on that you can decide when you're looking to buy a new car. Okay, next is the final product. Now we have factors influencing your automotive design. Now these are all the various factors. Okay, we have cost analysis, package, production methods, sales and market, quality, aerodynamics, regulatory requirements. Now what does this mean? Each country will have its own regulatory norms. Okay, as we know, recently India went into BS6, so that is also a norm. So certain countries would have their own types of norms and regulations that we have to follow. Certain would tell that you're not supposed to bring, you know, like the sky, like what do you call that, those coupe cars they're having, right? So all those things would not be involved. Some countries would ban such thing. Some countries would, like suppose in India, the ease with which you can travel using a luxurious sports car, it's very low. Okay, you know about the potholes and the huge humps that we have. You might have seen some funny videos where a Lamborghini gets stuck, or a Rolls Royce gets stuck, all those stuff. So it depends on each country and their terrain and their regulatory norms and everything. Got it? So then we have corporate strategy, brand image, customer demands. So these are the factors that influence the automotive design. So for today's session, we'll be winding up here. Okay, so tomorrow we'll be going on with the next one. Okay, so we'll be going with the use of softwares in these particular domains. Okay, so we'll be doing that tomorrow. So like I'll be telling you about each software and what kind of industry it's used predominantly, and what is the advantage of having that. Got it? So any doubts? So how was the session, guys? Till now, till this point, let me know how was the session. So if it was awesome, type AWE. If it was boring, type BOR. Okay, good, good. I hope I was able to provide some valuable information to you guys. Okay, okay, okay then. So any doubts till this point? Any doubts you have regarding any specific process? If you have, you can let me know. Or if you have any doubts with respect to software, also you can let me know. I don't mind. Okay, so tomorrow come at the same time. Tomorrow will be starting at 4 p.m. exactly. Today, because of some technical issues and some people couldn't join immediately, that's why there were some issues. Sorry for that. So tomorrow will be beginning exactly at 4 p.m. Okay, any doubts, anything, you can let me know. Okay. We'll be sharing you the recording, but unfortunately, due to company policy, we won't be able to share the slides. Okay, we'll be sharing you the entire recording of the session after it's done. Okay, after tomorrow. Yeah. Okay. Any other doubts? Anything you can let me know. We'll also share you our website. Okay, on the group you can check it out. So we do have courses on various softwares. So today, if you're free, you can just go through them. All the various things that we cover up. Okay, so this is just an overview. So when you join or when you enroll into our courses, so there you'll be learning from right from the industrial experts. Okay, so each of these terms which I've told will be going in depth. Okay, so what is drafting? So what are the various tools in that? Okay, okay then fine. So we'll be going in depth into all those terms. So anyway, tomorrow we'll be covering up that. So thanks a lot. You guys were an amazing crowd. You guys responded very well, and as I hope you interacted very well. Even I'm happy. Thank you.